is uncertain, incomplete, vague, imprecise, ambiguous, inconsistent, subjective, dynamic. These are distinct types, and each will be explained. First of all, we take what are the major sources of imperfections in human knowledge. Knowledge is product of human mind, an image in the mind of the objective world around. Human mind is finite and discrete. To store the image of the objective world, which is potentially infinite, continuous, and dynamic. Hence, image in the mind can be and actually is only an approximation of the objective world. Neither is nor can ever be exact or complete. This was stated by the great philosopher North Whitehead, the teacher of Bertrand Russell. Perception and judgment are basic human tools for acquiring knowledge, both of which are imprecise. Earth is flat. It is because of the lack of, it is our judgment which is not precise. It was thought long back. Earth is the center of the universe, again because of the imprecision in our perception and judgment. Friends, judgment may be thought of as conclusion or decision, arrived at by not going through complete systematic conscious efforts. Friends, the second major source of imperfection is randomness in nature. Randomness, by definition, is group deterministic but individually non-deterministic, is now believed to be the objective and not due to the human limitations. That is, randomness is not because of the human limitations of perception, but rather it is a phenomena in the nature itself. For example, number of children that will be born in a particular period, it is a random phenomena. Number of persons falling ill in a given month. Even simple activities like tossing a coin or throwing a dice. The result is intrinsically random and not because of human limitation. Outcome of a toss of a coin is group deterministic. That is, the output will be either head or tail. But it is indeterministic so far as individual result is concerned. Similarly, motion of an electron in an atom is also random. Types of imperfections. Dinosaurs, another very major role, as I'll explain, is the natural language. For example, here for a long period, this phrase stands for periods from few hours to thousands or millions of years. For example, dinosaurs ruled the earth for a long period, about millions of years. It has not rained for a long time, say about 6 months. I had to wait for the doctor for a long time, at most about 6 hours or so. So, friends, the phrase for a long time is an example of both ambiguity and vagueness. Ambiguity is resolved by each of the three contexts. Like in the case of dinosaurs, it is millions of years. In the case of rain, it may be 6 months. And in the case of doctor, it may be 6 hours. But the vagueness is not resolved. Friends, fuzziness is another character, particularly in the natural languages and also in the nature. Young and old, these are two, but we don't know when a young person gaining after some years becomes old and all that. Similarly, spring and winter. When the spring becomes winter, there is not a deadline or a point where we can fix that now it is the winter point. So these are gradual changes, phenomena. These are major sources of it. Actually, natural language is a major source of almost all types of imperfections in human knowledge. Friends, next we discuss the various types of imperfections. The first is knowledge is uncertain. The knowledge is uncertain, that is very easy. It is about diagnosis of the problems of disease. You are not certain. Only you have the symptoms, but not the disease. Predictions about weather generally nowadays are quite reliable, but not completely. These are not certain. Historical facts possibly biased, and conclusions based on sample data. Also, knowledge in respect of each of the following types of scientific matters is uncertain. The path of an electron in an atom is uncertain. Existence of most of the fundamental particles is uncertain. Existence of life somewhere other than Earth is uncertain. existence of some other universes having different physical, chemical, and biological properties and having phenomena different from the ones known to humanity is again uncertain. Then the data, the knowledge may be incomplete. Sample data for massive phenomena is by its very definition incomplete representation of the phenomena. So is the knowledge of the natural phenomena based on any scientific model theory explanation of the phenomena. E.g., based on Newton's theory, because a theory is finite representation of a large, generally infinite phenomena, so any theory has to be incomplete. Then the third type of imperfection is vague or fuzzy. The knowledge is vague when there is difficulty of marking sharp or precise distinctions in the problem domain. E.g., when knowledge involves linguistic or qualitative variables like tall, fast, tall, short. In India, males of height 5 feet 10 inches and 6 feet 3 inches both are called tall without any distinction. A person of height 5 feet 9 inches may be tall in India but not in USA. So the tall and short concept, you don't know at what point after gaining a few inches, a short person becomes tall. Fast and slow, and email, if not reaches within 5 minutes, then it is slow. A conventional mail, if it reaches within 2 days, it is fast. Then another type of imperfection in our knowledge is imprecision. Imprecision arises when values of a continuous real variable like time, length, area are attempted to be represented in terms of some computer discrete numbers. In such cases, the values in the range of n minus epsilon, n plus epsilon, where n is an integer and epsilon is machine epsilon, all are represented by single value n. In electronic watches, computers, howsoever precise the time may be, it is still approximate or imprecise. Friends, we may note that the three terms vague, imprecise, and ambiguous are distinct. The significance of knowing the distinctions lies in the fact that different mathematical models are developed and useful for each of these types of imperfection. Now we discuss mathematical models. Friends, a number of mathematical models have been developed to tackle different type of imperfections in knowledge. We know probability theory, fuzzy set theory, fuzzy measures, and its special cases, belief measure, plausibility measure, probability measure, possibility and necessity measure, all of which are symbolic and primarily numerical, but may involve inductive or deductive reasoning in the matter of providing rules. Then there is another category of models for handling imperfection in knowledge. Modal logics, belief models, and non-monotonic logics are mainly non-numeric, symbolic, and follow deductive approach. Rough set theory is primarily an inductive approach. Chaos theory, neural networks, genetic algorithms, and swarm intelligence etc. are sub-symbolic and quantitative approaches in which chaos theory is primarily deductive, whereas the others are inductive. Friends, now go a little bit further in each of these models. Probability theory, it is the main mathematical tool to solve problems of randomness. And the contributions to the development of the discipline, the earliest known forms of probability and statistics were developed by Arab mathematician Al-Khalili, 717 to 786, and Al-Kindi, 801 to 873, and Ibn Adlan from 1187 to 1268. Modern probability theory was initially developed by Cardano, Fermat, Pascal in 16th and 17th centuries. Friends, other models of handling imperfection are fuzzy set theory and rough set theory. Fuzzy theory was proposed by Zadeh in 1967 to handle the problem of weakness, young and old. E.g., a 30-year-old man can be said as zero point 0.7 young and zero point 0.3 old. Rough set theory proposed by Pollock in 1982 is an approach for simplifying massive data through the concept of equivalence classes. For example, framing timetable for thousands of students is done by designing it for class subject equivalence classes instead of doing it for each individual student. It is primarily an inductive approach for finding significant attributes for classification. Friends, models for handling imperfection. Next model, chaos theory. Some earliest contributions to chaos theory are attributed to Poincare during 1980s, three-body problem. Adam Earth in 1898, motion of a free particle, Adam Earth's billiards. Lorentz in 1972 through his butterfly effect and Lorentz retractors. Small a in 1960, small a horseshoe. And Mandelbrot, who is very well known for this, in 1967, how long is the cost of protein? Friends, chaos theory handles imperfection when the appearance is irregular, but underlying rules are deterministic. That is, it is a mathematical model for handling imperfectness found in chaotic systems, where a chaotic system is a dynamical system in which minor differences in the initial data may lead to substantial changes in the behavior of the dynamical system. We take an example here. Friends, in Canada, Divide Creek is a rivulet which splits into two branches near Kicking Horse Pass on Alberta, British Columbia border. One branch flows west into the Pacific Ocean. The other flows east into the Atlantic Sea. Friends, for a pair of adjacent drops, one may go to the Pacific and the other to the Atlantic. Just in the initial conditions, by chance, which drop goes to the west and which goes to the east. The differences lead to thousands of miles in their final destination. So this is what is chaos theory about. A substantial part of our knowledge is not factual, but in the form of commands. Now it is another type of models. So far we discussed the models which handled factual knowledge, but now it is something of different type of knowledge is also there. A substantial part of our knowledge is not factual, but in the form of commands, obligations, and possibilities. For example, modal logics handle this type of things which deal with necessity and possibilities. It is necessarily happens in the nature and it possibly happens in this type of situations are handled by modal logics. Then deontic and imperative logics deal with respectively permissible, obligatory, and commands, religious injunctions like do this, don't do this, belief logics, non-monotonic reasoning systems. So friends, these models are which handle with the possibilities, commands, and obligations. Friends, further models. A paraconsistent, most of the time, most of the logics have been developed for the purpose of finding consistent, treating consistent knowledge. That is, if you have a pair of mutually negated statements, then ultimately anything can be proved. And therefore, if by chance, as in the case of large databases, if a pair of statements clash each directly or indirectly, then such logics become useless. Taking this thing in mind, para-consistent logics have been developed. A para-consistent logic is a logic concerned with studying and developing inconsistent tolerant systems of logic. The logics accommodate inconsistency in the controlled way that treat inconsistent information as potentially informative. Excuse me. However, the classic logic is not rejected outright by para-consistent logicians. The validity of classical inference is usually accepted in consistent contexts. The rejection of ECQ, any arbitrary statement as is concluded from two contradictory statements, motivated by the need of isolating an inconsistency without it spreading elsewhere. There are a number of systems of para-consistent logic, including discursive logic, non-adjunctive systems, preservationism, additive logics, logics of formal inconsistency, many valued logics, and relevant logics. Friends, we come to the last part. Out of the many domains, now I'm coming to what are the research domains involving imperfect knowledge. Friends, out of the many domains we just mentioned, only three here because of the lack of time. Mechanization of common sense. The second very important domain from the point of view of research or state of art involving imperfect knowledge is unconscious knowledge. And the third is natural language understanding. Friends, what is common sense? Common sense acquired mostly unconsciously, used both consciously and unconsciously. Most of it is acquired unconsciously through interaction with the world around. I'll give you some examples. It forms a very large part of human knowledge. This may be more than 60 or 70% of human knowledge of a common man. This implicit knowledge has to be explicated for embedding it into the machine. And most of common sense knowledge is imperfect. Let us have some examples. A person dies only once. We have never read in any book, but we know it. Even a child knows. All parts of a body of a person are where the person is. Almost every child knows it, but hardly we teach it in a book. A stone is not hurt when hit, but a dog is hurt when hit. Only a living entity can feel hungry and eat. Water flows down hills. A rope is used to pull, but not to push. Millions of such facts are stored in our mind, most of which are acquired unconsciously and used unconsciously and consciously also for making decisions and solving problems. I repeat, all these facts are generally acquired through experience, and we explicitly don't know when we are solving a problem using any of these. And such millions of such facts are stored in our mind, and we use these every day in solving problems without our being aware that we are using these facts. So common sense plays a very important role in our survival, and it is also used in academic purposes for particularly making models and all that. Challenging. Now I come to what is the challenge from the research point of view. The role common sense plays in everyday life on one hand, and the difficulty of embedding it in the machine on the other hand is well explained by Ernest and Davis, Common Sense Reasoning and Common Sense Knowledge in AI by Ernest Davis and Gary Marcus, 2015. Friends, I'm giving you the details of attempts at mechanizing common sense. How much difficult it is to create common sense, knowledge base, common sense knowledge base can be judged from the well-known CYC project initiated in July 1984. That is, you can say about 36 years back by Douglas Nainet and Ramanath Guha. Its First stable release 6.1 came on 27th of November 2017 and still going on. So you can see how difficult it is to mechanize common sense knowledge, which forms a very large part of everyday our knowledge used in everyday problem solving. Even before CVIC project began, in order to estimate the complexity and time to be taken by the project, a conference in 1983 was held. Calculations by some of the pioneers, most of them are Turing awardees of AI, including Marvin Minsky, Alan Neville, Edward Feigenbaum, and John McCarthy, estimated that the effort would require between 1,000 to 3,000 person years of effort. So, friends, common sense, which is a big asset for human beings in solving everyday problems and even intellectual problems, is very hard to be embedded in the machine. Second, the unconscious part. Friends, it is said that our knowledge, 90% of that lies in our unconscious mind. Unconscious knowledge includes most of our how to knowledge skills, capabilities of understanding a phenomena, easy language understanding or visual understanding, finding and propounding principles, making proper judgment, acting properly without explicit calculations like crossing a very busy road, strategy making, creativity, getting a novel idea impromptu, correct action taking or decision making, e.g., Newton's ideas of theory from falling apple, or of abstraction or summarizing and common sense. Friends, these are the some of the activities which we do because of our knowledge and unconscious capabilities. Unconscious knowledge consists of our habits, vague intuitions, and gut feelings. Most of it is purely procedural knowledge, is repeatedly used and experienced. However, underlying brain mind mechanisms for acquiring such knowledge are not explainable or communicable to others and even knowable to oneself, as in each of the following cases. Composing a poem by a poet. Poet can't tell the brain mind mechanisms by which the ideas strike to her. Getting a novel research idea of gravitation from falling apple. Newton could not have explained the brain mind mechanism which led to the idea, but until unless we know the brain mind mechanisms, we can't incorporate the capability in the machine. Unconscious knowledge is most of the time imperfect, incorporating all types of imperfections which I have mentioned. It is considered that human conscious capabilities constitute the proverbial tip of the unconscious iceberg of human capabilities. I said more than maybe 90% of more than 90% of our unconscious knowledge and capabilities help us in everyday life. This is the most challenging domain for mechanization. Recent contributions to modeling unconsciousness, though nowhere near satisfactory, include global workspace theory proposed in bars in 1988, 97, and 2002. Cognitive architecture LIDA developed in bars 2009 and Franklin 2007, 2006, and 2000. Unconscious thought theory proposed in Dijkstra's House in 2006. So friends, you can see the unconscious knowledge and capabilities, which form a very large part of human capabilities, is so far unmechanized, not very satisfactorily mechanized. Now, finally, I come to the last domain, natural language understanding. And natural language form a very major chunk of our imperfect knowledge. It is well known fact that natural languages express human feelings of joy, sorrow, humor, surprise, etc. quite satisfactorily, especially through various figures of speech. e.g. metaphor, simile, irony, euphemism, and hyperbole. Rather, a large part of our being human, distinct from the other animal species, is because of our using natural language. However, these figures of speech make a natural language ambiguous, vague, imprecise, and even inconsistent, and hence make a natural language unsuitable as a mathematical or scientific language, where objectivity, clear and consistent meaning is foremost concern. Actually, during 19th and 20th centuries, investigations in the fundamental reasons for crisis in mathematics, use of natural language in definitions and proof was found to be one of the main culprits. So, friends, whereas natural language is really our big asset, and particularly for life, making more enjoyable or sorrowful or whatever it is to express ourselves as a human being. But from the computational point of view, this is very weak. Friends, here the situation is much better as compared to in the case of unconscious knowledge and in the earlier cases, etc. This domain, or in the case of common sense reasoning capabilities, here it is quite satisfactory as compared, but still it is a lot of work is to be done. So this was, friends, conclusion. In summary, while designing software for hard problems or applications, it is essential to keep in mind that human knowledge, which is used in the design, is essentially imperfect. There are various types of imperfections in knowledge. For any type of imperfection, only some particular mathematical or computational model is or are appropriate. Therefore, in order to avoid disasters, particularly for critical applications, it is essential to determine types of imperfection in the knowledge to be used and appropriate imperfection type model match. Friends, these are some of the references. Thank you very much. Again, with gratitude to my respected teacher, Professor Bhudev Sharma. Questions, please.
Okay, thank you, Prof. Manohar, for your interesting presentation, which is, I think that is very insightful. I hope everyone feel it, your presentation is informative. May I invite the question from the floor? Okay, Prof. Manohar, I have a question. Okay,
Yeah.
recently, there is I'm not saying that it's a new branch, but it's a new trend in AI community that we have a research that emphasis on explainable AI. What do you think of this trend in view of the challenges that you mentioned just now about the knowledge? How I mean, how the researcher in this field can advance?
Well,
His advice.
Professor Dan, thank you, sir. Well, main thing is that explanation knowledge, AI. First of all, it is must be based on the logical grounds as against now machine learning techniques based on statistics and all that. So one thing is somehow the logical approach has gone out of fashion because of the machine learning's deep learning and all massive calculating power of the machines. So somewhere I feel first of all that translation from the natural language to the machine language is first step, and secondly the logical approach has not to be abundant completely. That is the two parts, that is the statistical approach as well as the logical approach may have to be combined together or may have to be married in such a way that the logical approach also is, because mainly the explanation is possible through the logical approach. So this is my feeling, that logical approach, which has nowadays is not very much in vogue, has not to be abandoned completely, and it has to be married with the deep learning and all the statistical approaches. This is my feeling.
Okay, thank you for your viewpoint, Prof. There is another question from me. Between inductive learning and deductive learning, which type of learning is more applicable to fit in the current need? I mean, and also the future.
Well, Professor, again, deductive and inductive are respectively the logical and statistical approaches. So partly I answered this question earlier also. Deductive reasoning is a sort of logical approach in which you use the various logics, predicate, propositional and all that, whereas the inductive approach is mainly statistical based. So naturally in some, and no approach can be the best approach in all situations, otherwise the other approach goes into the history books. So what I have said earlier also, the two approaches have to be married, and each has its own advantage. Statistical approach has that it can analyze the massive data based on the earlier happenings in the but ultimately, when a doctor, a rubber doctor diagnoses a disease, we like to have the explanation also behind the conclusion or diagnosis. So that thing can be implemented if we side by side use the logical or deductive approach also. So this partially answers the question.
Yeah,
Professor
thank.
Gopal,
Yeah, maybe
Yes.
Prof. Gopa have some.
uh,
You have
Do
Professor
an
we?
opinion?
Gopal.
Would you advise a restriction on the modeling for the sake of preserving life forms? Mathematical models can simply go on expanding unto a theoretical infinity. Where do we draw a line, and would you advise that?
Professor Gopal, it is really very quite interesting and subject. So once again, I repeat what I said in the very beginning, that human knowledge is imperfect because of the reason that the human capabilities are finite and discrete. The nature is infinite and continuous. So again, my answer comes from that particular statement. Human capabilities were, and whatever is embedded in the machine is only what we human beings realize from the nature through our mental capabilities. So what I mean to say, life is infinite continuous.
Okay.
Machines are partially answering our questions, but I really like your question very much. But the machine answers the problems of the past. And in view of the new mechanical and other human intellectual development and machine developments, a new environment is created. Nature is very sharp. Nature will not allow it to grasp it completely. In the sense, every new mechanical or capabilities of the computer systems or AI systems is creating a new environment, which is because of the infinite continuous nature of continuity of nature. And it therefore, whatever is embedded in the machine will always be deficient. It will be creating its new type of problems. For example, Professor Gopal, now most of the functions are being implemented, are being attempted to be implemented by the machine. A graduate who spends 25 years of his or her life, at the end of 5 years training, postgraduate training, finds his job or his functions or his capability, whatever he or she can be do, can be done by the machine much better. What I mean to say, the nature evolves faster than us. we can grasp. So this is my answer to this one, that somewhere machine will not be able to answer. We might have, I remember a book in 1948, I forgot the name. The book was written in 1984, it quotes some great scientists. Human beings have opened Pandora's box through artificial intelligence and genetic engineering. Where it will lead, nobody knows. But at least it is sure that it will displace the humanity itself through its own actions from the center stage of the earth. So what I mean to say, problems will continue. Machine may displace us as intelligent entity, but it may not finally make our life happier or better. This is my answer. I don't know whether I am able to answer your question properly.
No, no problem, sir. I understand. Thank you. I am rushing into a class. Thank you so much.
Thank
Okay.
you.
Thank you, Prof. Manohar, for your presentation. Okay, which is very interesting. And if there's no more question from the floor, I would like to close this section, and we shall meet again in this afternoon in Japan time. Okay,
Thank you
which
all.
is, thank you. And then we shall meet again at 2 p.m. In Japan Standard Time, which is 10:30 in Indian Standard Time. Okay, see you again. Thank you. Bye-bye.
See you. Bye.